Show by means of suitable sketch graphs that the equation x minus 2 to the power 4 equals x plus 16 has exactly two real roots. State the value of the smaller roots. Use the iterative formula given here with a suitable starting value to find the larger root correct to 3 decimal places. Okay, let's have a look at this then. Okay, so we've got this quartic equation, isn't it? X minus 2 to the 4, and we've got this straight line function here. So I'm going to do a quick sketch here, just an informal sketch with a digital pen. Of course you'd use a ruler and a far better grid axes than I've drawn here. So x plus 16 and x minus 2 to the 4. Now this would be a quartic equation, but it's very similar to x minus 2 squared, I would imagine. It's just that the values go up much more steeply in terms of their size. So it's this squared, isn't it? So if we draw x minus 2 squared and then just realize that the scale is a lot bigger than it is before, because it's that squared. Okay, x minus 2, so here's 2. So this would be a line of symmetry. So I'll put that in. And then when x is 2, we get 0, don't we? And then it's basically going to shoot up really, really fast, like a stretched up quadratic. Still a U-shaped curve, but it's shooting up so much more quickly than just the quadratic. So this is y equals x minus 2 to the power 4. Now the straight line x plus 16. So we're here at 16, and we've got a straight line. So it's going to just come along here straight away. I'm drawing it with dashed lines because it's easier with a digital pen. And that line there is y equals x plus 16. So we can see there's two roots. Two roots are demonstrated as in evidence here and here on the sketch. So that's what we've got there then. State the value of the smaller root. So this value here, what would it be? So it looks like it's going to be between 2 and 0. So let's have a look here, between 2 and 0. Okay. If it was, it's not going to be 0. Although minus 2 to the 4 is 0. So x equals 0 gives minus 2 to the 4 is equal to 16. So it actually, this 16 value, this curve is a lot flatter. So I'm going to draw it a lot flatter now. So it's not quite as steep as I suppose. This 16 should be way up higher anyway. So here's our cubic curve, here's our y-axis, and this is the value 16 here. So, and it's probably more accurately drawn now, so thankfully we found that value, and we can put in the proper sketch now. So here's the 16, like so, and that's a much better sketch because we found there was a root here when x is 0. So the curve's been adjusted now in the light of the fact that we found the first root at 0. Now there's another root here, which is going to be well above 16, of course. So this is the iterative formula. So if we try something above 2, let's try 3 for example, in this iterative value, we should work up and find the solution here. So let's use this iterative value. So this is part 2, wasn't it? And the root was at x equals 0. This was part 1, where we did the 2 sketches. Now we do part 3. And we're going to use that iterative formula here. So x to the, let's just write it down. 2 plus the 4th root of x to the n plus 16. And we're going to put 3 in to start with, and then we're going to work out the values, and we want it accurate to 3dp. So let's get our calculator. It's 2 plus bracket 3, but we're going to put answer in here, so let's just put 3 as the answer, and that's in memory as an answer now. So I want 2 plus bracket answer 3 plus 16 bracket power 0.25, because that's a quarter, isn't it? So put it in as a decimal. Come down to ground level, equals, we get 4.08, and then just keep running it through 4.117, and then we suddenly finally settle down to 4.117. 4.117, and that's to 3 decimal, 4.118 to 3 decimal places, but I'll write it more accurately first. So here, value is equal to 4.11. Let's have a look. 785. 785. And that was the value we determined from this iteration process. Okay, so if we type in a value to 3dp, we need to try 2 values, don't we? We need to try 4.117 3dp. For it to be 8, we need 7.5, and we need to try 4.1185 and find the difference in the function here for this root. So x minus 2 to the 4, and then it was equal to, so it's minus the x plus 16, so it's minus x minus 16. This will be our f of x in question then. So we want to try this value, try these values to show the root exists between these two. One will be positive, one will be negative, hopefully, and then we verified that to 3dp it's going to be 4.118. Let's try that then. So we've got 4.1175, wasn't it? And now let's just do equals on that, and that is our fraction then. There it is there. So it's answer minus 2 minus 2 bracket to the power of 4. All of that is in the bracket because it's power 4, minus the answer, minus 16, equals negative. So that was negative. So f of 4.1175 is equal to small negative. And now f of 4.1185, and we should hopefully get a small positive now. So we'll have to put that in manually, I think, here and back here. So 4.1185 there to power 4 minus 16 minus x, wasn't it? So it's 4.1185 equals positive small. Okay, good. So there's a root between these two. So root equals 4.118, and that's to 3 decimal places.